When we have areas or features of complex geometry, and those features have some distinct attribute that are clear in the data, then we can use an auto tracker to map those features. An example we have here is a fractured surface, and in this surface the fractures are very clearly visible, not just in the RGB image, but if I switch in here and go to our coplanarity attribute, those fractures are clearly visible in that attribute as well. And we can also look at other attributes such as change of curvature. And let me just modify the histogram, and again we can see these fractures being pulled out very nicely and very clearly. The scale bar here is 1 meter and each band is a 10 centimeter increment, and the purpose of this tutorial is to run you through the auto tracker, what the features are and what you can do with it. To initialize or start our auto tracker, we need to firstly make the mesh active, and that brings up the extended mesh menu. And the auto tracker lies within the menu here under this track panel. And there's several different parameters that we can modify based on what we're working on. The first thing we do is we're going to switch on an attribute that we want to track. So here I'm going to track on coplanarity. Then I'm going to go to tracker and track minimum. The value we're looking at here, so flat areas have high coplanarity and less flat areas have low coplanarity values. So that's why we're going to be tracking low coplanarity. So we want to track the minimums. Select that and the auto tracker will initialize. So this is restructuring the data to make the tracking process much quicker. It's a one-shot process. So when you first start auto tracking, you have to initialize the auto tracker, but once it's done, you don't have to keep reinitializing it. It's a one-shot process. So we have to wait a minute or two for this to initialize. It can take a minute on large data sets, but we'll just wait a moment for it to initialize here. Now that the tracker is initialized, we can select a feature to track. We'll start off with something quite straightforward. Let's work on, say, this segment here to start with. So tracker, track minimum. It's initialized already, so we don't have to go through that initialization process. Click our first point and then click the second point. Give it a moment and it's tracked along that low coplanarity value. I'm going to go here, double click, and it should then take us to the end and give us a surface. Now, this is a very small scale data set, so the vertices and projection points and line planes are a bit big. So let's go into our properties here. We'll reduce the vertex size to 1 centimeter, and we'll reduce the projection distance of the planes to 5, keep it nice and small, and we will actually for the moment switch the planes off. So we just have our vertices and lines showing. Right, so there's our first auto-tracked line. Let's try something a little bit more larger scale then, or for a longer distance. Let's do this one. we'll try auto tracker. Again, we're tracking a minimum. I'm going to go straight from here to here in one go, and let's see what happens. Now, what it's done, it's found that there is a very strong low value that goes all the way around here. So it's found this path sticks to very low coplanarity values, and it's not gone along the path that we expected at all. There are some areas of relatively high coplanarity in here, so it's found a route where it can stay on lower coplanarity values. There's a couple of ways that we can work around this. Is if I do Control Z, it undoes the last interpretation step. We could just put in several shorter segments and allow it to auto track that way. And it's all building up the auto tracking now. This is quite a large data set, so the tracker does take a little bit of time. There we go. And there's our tracked surface. So that's one way of doing it. And then the other way is to modify the tracking parameters. So let's go back to track minimum. We select a point there and a point there. And that should give us where it tracks round the outside again. We can modify the way the tracker works by using the parameters in here. So we have strength, which is really a control on the sensitivity of the tracker. As we increase the strength of the tracker, then it will track across larger value changes. So generally speaking, we want to keep the strength quite low. But the other option that we have is the balance. By default, the balance is set to be 0, which means that it tracks entirely on the attribute. But if we change the balance and increase it, the balance handles sort of weighting the tracking between the attribute and the distance between the point. So if we were down at 0, it would track entirely on the attribute and set the balance all the way over to the right hand side here. It will track based just on distance. And I could show that by tracking a minimum here, and let's go from there to there. And what we should see here is that it just basically tries to track the shortest path distance-wise from one point to another. And by blending the two values together, we can improve the way the tracker works. If we go back here and we were tracking over to down here before, so I've set the balance to be around 0.5. So it's using a combination of both the attribute and the distance. So let's go back down here and click there. And this time we find that it tracks as we wanted across that fracture. If I do Control Z and let's bring the balance back down to 0, so using attributes alone again. Click once more. And it's again finding a very low, tortuous route, but keeping to minimum coplanarity values as much as possible. So using a combination of these two allows you a lot of flexibility in your auto tracker. Now once you've got your line tracked, so we should complete there. Zoom in, select the line. This might have too many vertices for you. You might want to decimate it. So let's just go to polyline here. So make sure it's active. And we're going to, let's show the plane. There we go, that's better. Operations, we can start with a refine by spacing. I'm going to do this to 0.005, so half a centimetre. And we can see that that had reduced the number of vertices in there, so I think that needs to be done a little bit more. Let's reduce to 1 centimetre. Then we could also do adaptive refine. So this is an angular refinement. It reduces the number of vertices in straight segments. And we've managed to reduce the number of vertices and still maintain the geometry. So that's how you can use your auto tracker to map attributes in a digital outcrop model.